We're joined by Rüdiger Seine, I think, Dr. Rüdiger Seine, and we've got Meganne Christian, who is one of the UK's new members of the Astronaut Corps. Hello, Meganne. Can you see us? Can you hear us? Are you there?
Hi, yes, I can.
Hey, nice to see you. Where are you? Am I right? Because I know you were I think you were in the Johnson Space Centre 5 minutes ago doing exciting
yeah, so
things.
I was there last week, but now I'm back in Harwell today.
Oh, okay. You're back in where are you?
Harwell.
Oh, Harwell in Oxford. There we go, near Oxford.
Yeah.
Oh, well, listen, thank you so much for joining us on Mars Day. You've got such an amazing story. Everyone's going to be wanting to know about what you've been up to in the last few months since you got selected to join the Astronaut Corps. And I know you've got a presentation. So the floor is yours if you're ready to go.
All right, thank you very much. So I'm going to share my screen so you can get a bit of an impression of what the astronaut selection process was like, and then I'm going to hand over to Rüdiger to talk about the training process. But first of all, so here's my story of the selections. So in early 2021, the European Space Agency opened up applications for astronauts for the first time in 13 years. They made this beautiful little model where you could put your face in there so that you could feel like anybody could apply to become an astronaut. And that was almost true. These are the requirements to apply. So, of course, you had to be a citizen of a member or associate member state of the European Space Agency. You had to have a master's degree or higher in natural sciences, which includes a whole range of sciences, also engineering, mathematics, computer sciences, or on the other hand, you could have an experimental test pilot degree. After that degree, you also had to have 3 years of relevant professional postgraduate experience. You had to be fluent in English, and knowledge of additional languages is an asset. So not a requirement, but definitely helpful. Of course, you have to have a strong motivation and ability to cope with irregular working hours, frequent travel, long absences from home, family, and regular social life. You have to be flexible with regards to place of work because astronauts travel a lot, both during their training and afterwards. You have to be calm under pressure and willing to participate in life science experiments because that's a lot of what you do up on the International Space Station. There are also some physical requirements. So there's a height range between 150 and 190 centimeters. I'm short, but fortunately fell within that range. But there was also an astronaut with a physical disability selection, which I'll talk through in a minute, which could have applicants under 130 centimeters as well. You had to have a normal BMI, which defined by the World Health Organization, which I believe is between 18 and 25. You had to have visual acuity in line with the requirements for private pilots. So the first thing that you had to do when you applied was actually to upload a medical certificate from an aviation doctor. And you had to have a hearing capacity of 25 decibels or better per ear. So they're the physical requirements. It looks like a lot, but a huge amount of people actually satisfy these criteria. I'm sure most of you will as well once you get a bit older. But about 22,500 people applied based on these criteria. Now, I mentioned the astronaut with a disability feasibility study. So this time the European Space Agency put a lot of effort into a diverse selection. There was a lot of push to try and get more women involved. And at the same time, there was also a push for the first time in history to have qualified professionals living with a physical disability with the possibility to become an astronaut. So this was a special project that the successful candidate would join the Astronaut Reserve and participate in the Para-Astronaut Fly Feasibility Project. So that's the idea of that, is to investigate the feasibility of sending an astronaut with a physical disability into space. What needs to be changed in terms of the training program? What needs to be changed in terms of hardware to send somebody with a certain type of disability into space? So, of course, you have to start somewhere, and as I said, you have to start somewhere. And so there's a range of disabilities that this study covered. So people with these type of disabilities could apply in this particular round. In the future, I'm sure this will be expanded into other disabilities as well. So in this case, the possible disabilities were a lower limb deficiency, such as the single or double foot deficiency through ankle, so amputation, for example, below the knee also, or a pronounced leg length difference, also short stature, like I mentioned before. So these particular disabilities were chosen because you have to be able to work out where to start to then expand into other disabilities. So these were the criteria that were taken into account. So people with these kind of disabilities should still be able to read procedures with the help of minimal visual aids, execute verbal commands and understand instructions, verbally communicate with ground and other crew members, operate, maintain and repair systems, stand, move autonomously, have the psychological ability to remain calm, and also work in confined spaces. So for everybody, the selection process was the same. That's for the astronaut and astronaut with a disability selection process. The first thing to do was to submit a CV and motivation letter and answer a questionnaire. And as I said, about 22,500 people made this step, also uploading their aviation medical certificate. So there was a big screening process to cut that down to around 1,400 people for the next round, which was a series of computer-based tests. On these computer-based tests, we had to share our knowledge of things like physics and mathematics, logic, and also working with a joystick, so our hand-eye coordination. And from there, about 400 people went through to the psychological round. Now, the psychological round was at the European Astronaut Centre in Cologne, which we'll see in a minute. And it consisted of some teamwork exercises, some pair exercises, as well as a series of interviews with psychologists, both individually and with a panel. And approximately 100 people got through to the medical selection from that round. And that was a full week of medical testing. There were many, many different types of medical tests that they did. Eyes, ears, but also every other part of your body, just to make sure that you were likely to be healthy for the rest of your working life as an astronaut. Because there's a lot of investment that goes into astronauts, and there's a lot of physical difficulty that astronauts have to endure. So they have to be in good physical condition to start with. From there, about 50 people went through to a panel interview. And I personally found this actually the most difficult part of the process. Panel interviews are quite normal for any kind of job, but I don't know, I found this one particularly tricky because any time that the interviewers thought that I was in my comfort zone, they would take me out of it and ask me to talk about something different, something that I might be less comfortable talking about. And it ranged from questions about hypothetical situations that you might encounter in space to questions that you might be asked by students or by journalists or even by politicians. From there, the last group went through to an interview with the Director General of the European Space Agency. And that was a more relaxed kind of interview. It was kind of just a chat with him. He wanted to get to know us so that he could make his final selection. And then in November, and I think one of the main reasons that I got through was because I had spent a year in Antarctica. And if you want to hear more about that, you can come to the Space in Science in Space session later this afternoon, and I will talk some more about that. But it was definitely my experience of isolation, working with a small international crew, and spending time overseas in extreme environments that helped me get through that whole selection process, even though I wasn't sure that I would get through each individual step as it went on. It was a long process. It took about 18 months, and there were so many people, so I wasn't expecting to get through. But in November 2022, the astronaut class was announced, and this is the class here. So there are 5 career astronauts. That means there are 5 flights available at the moment. So there are 5 astronauts who are going through their basic training. They'll be finishing very soon, and Rüdiger is going to talk about that. And the rest of us make up part of the reserve. We also have John McFall, who's British, and he's the world's first para-astronaut. That's the flight feasibility study I was talking about for astronauts with a disability. As I mentioned, the rest of us make up part of the reserve, and that means that if flights come available, then we could be called on to do them. And in fact, one of our class, Marcus Font, has already flown. So he was at the International Space Station just a couple of weeks ago, and I got to catch up with him last week, which was wonderful. Hear all his adventures on the International Space Station. So he did, in a very condensed way, a lot of the training that you'll be hearing about in a minute. The rest of us, including myself, we're waiting our turn and hoping very much to get that sometime soon. These are the kind of missions that we're training for. So we have the International Space Station, which is orbiting the Earth. It's about 250 to 300 miles above our heads in low Earth orbit. And that's going to be around until about 2030. And from then, there will be commercial space stations doing a similar kind of thing. It's a laboratory. So what you're doing up there is science, running science experiments. Then, of course, we have the Artemis missions, which are going back to the moon. And this time, we're not just going back there, we're going back there to stay. So there'll be Gateway, an orbiting station, and then eventually there will be stations on the moon itself. At the same time, we have robotic missions on Mars and going to Mars, at Mars. And the idea is that in the 2040s, we will have humans on Mars. So maybe one of you will get to go. So having said that, I'm going to pass on to Rüdiger to talk about the training. Rüdiger, you're muted. Can you take yourself off mute, please?
Thank you.
Thank you.
Can you hear me now? Excellent. Thank you very much. This is the type of technical difficulties we all run into. Welcome to the European Astronaut Centre in Cologne. And you can actually see astronaut behind me, Slavoj Božňanský, preparing for activities that he will do. This is the training hall where we actually perform most of the training for the international astronauts that do visit Cologne on their way to the International Space Station. Now, I've got a few slides and we will start with looking at a quick series of what is it that we train for. First of all, we're training for the International Space Station here. We're getting ready to train also for the Gateway station that Megan has mentioned, that's going to orbit the moon starting 2028 or a bit later, depending on how the development goes. But we're actually on our way to go somewhere even further, because the ISS is only 450 kilometers away, so it's actually closer than driving from London to the north of Scotland. It's just moving much faster than the north of Scotland moves around London, obviously. So if we take a look at the slides, and I unfortunately can't share them from here, so we have to do it via the back room. Those show basically everything that we have to train the crew for, and it starts, of course, with the trip. It needs a lot of training to be ready and safe on the trip, on the rocket, in the capsule, to get ultimately to the space station. And then the other critical part, of course, is coming back, because you have to slow down, you have to go through the atmosphere, you have a lot of heat generated on the outside of the capsule, and we want the crew to be able to deal with all that and take decisions where necessary. We also, of course, train the astronauts for the scientific work that they have to do, and that's two things. They have to be working as scientists on board the station. They perform experiments for scientists from all over Europe that have been selected, and they are, as I usually say, the glorified lab assistants that do the work. They're, of course, much more than the lab assistants. They know the experiments inside out. They understand where they need to take decisions, And because we don't have the professor there to look over their shoulder, they are really key to the success of the experiment. The other bit that they have to do is serve as a subject for life science experiments. Of course, we want to understand how humans behave and how their organism changes when they are in microgravity. It's one thing to be up there for a short period of time. It's a totally different thing if you're there for half a year. And you can see on the right-hand side, Tim Peake in one of our torture tools that was used to measure the strength of his leg as he was staying on board the station and going through the changes of the body that automatically occur. As our station is already up there for more than 20 years, it happens the same thing that happens also when you have a car that's more than 20 years old. It tends to break. There's repairs and maintenance to be done. You need to take it to the workshop occasionally. Unfortunately, we don't have a workshop. So what we do is we tell the astronauts where the repairs are necessary, and that is both on the inside and the outside of the station. Inside, you can see Alex Gerst here in a shirt sleeve environment. It's comfortable. You can move in shorts and t-shirt. You may need your headlamp to see inside the equipment that you're dealing with, but it's all relatively simple. Now, we also need to prepare training on the outside of the station, and that's where it gets really complicated, because ultimately the astronaut sits in a mini spaceship, and as this mini spaceship, the spacesuit, has an internal pressure, it has the tendency to try and stretch the arms and legs. So the astronauts have to continuously work against that stretching of the suit. And of course, they have to make sure they're tethered to the station so they don't lose contact and get lost in space. One more thing that is very important for the astronauts is to receive vehicles that bring new experiments, that bring the food, that bring equipment, all kinds of things. And while some capsules actually dock to the station automatically, others have to be captured by the astronaut with the robotic arm of the space station. And that is a highly accomplished mechanical task, because you need to use 3-4 camera views and then lead this massive arm and capture the approaching vehicle on a specific right point and then bring it to the station so you can berth that. That is one of the most challenging tasks that the astronauts have to do, and training for that takes a number of months to be able to accomplish it. And unfortunately, it is something that you unlearn very quickly. You forget very quickly. So we have to continuously keep the astronauts current on doing this activity. And the next one shows activities that we have to train for that you probably wouldn't expect. We have to train for normal life, because not everything that we do here on the ground works as easily on a space station. So going from left to right, using the toilet is slightly more difficult. And of course, the toilet has to be kept pristine condition for everybody who comes next time. That's very much like it is on the ground. Cutting your hair is different, because you can't let the clippings drop. The clippings would float and you would breathe them in and they would get into your eyes, let alone the equipment. So we're bringing the vacuum cleaner to immediately collect the clippings, as you can see here with Samantha Cristoforetti. You can see you need to do exercise to counter the negative effects on bones and muscles from not having gravity. And of course, getting your food prepared, doing your hygiene is all quite different. And we need to train the astronauts for all those things. And then, of course, there's the thing that we train for that we hope that never happens. That's emergencies. And we have essentially 3 things that we've defined as emergencies. That is a fire, obviously, a loss of cabin air by a little puncture in the hull of the station. And of course, if we release toxic substances into the cabin air, that would be very bad for the crew. The good news is most of these things don't happen, of course. If they happen, we typically have more time than one would expect. If you see a science fiction movie and there's a puncture to to the hull of a space station or a vehicle, the air goes out immediately because that's good for the drama. It doesn't on the space station. If it's a small puncture, you have hours, days of time to find the hole and plug it. But of course, you have to find it, and that's not easy. And we're training the crew for these things. Now, that is what we need to train for. And I've already said, I'm in the training hall where we're doing part of the training. If I step aside for a second, you can see the Columbus module mock-up. It's a one-to-one model of the Columbus research module that ESA has on the International Space Station. And that is where we take the astronauts to work. We also have right beside me a huge model of the old ATV cargo carrier that brought to the station cargo for the astronauts. And we're already starting with small models here, for instance, for the Orion module that's going to take the Artemis cruise to the moon. We have no big role in that yet, although the fueling section, the rocket engines, etc., are built in Europe, and the NASA astronauts that will go around the moon next will go there powered by European technology. Now, in here, we have the big training hall that I've already shown you. On the next slide, you can see that we also have smaller points where we train for the scientific experiments. Those are in basically a big shelf, drawer, rack, and we can do the training in individual rooms, so we can train several astronauts simultaneously. We also have a big pool that I can't show you now live, but it's on the slides. It is 10 meters deep, and this is where we train the astronauts for the extravehicular activities or spacewalks. So they go in there, they learn how to move, they learn how to deal with the weightlessness, and they learn how to do repairs and activities on the outside of the space station. What we do here is initial training. They get way more training on that when they go to NASA or to the Russian Space Agency that own the spacesuits, such that they can do the whole exercise in their respective environment. We also take astronauts as an exercise to learn how to deal with isolation and complex environments, similar to what Megan has mentioned she has learned in Antarctica. We take astronauts into caves. We bring them into a cave where they go as an international team, and in the next slide you can see an impression from that, where they work for more than a week inside a cave. It has a lot of the stress factors that you usually get in a space mission. It's uncomfortable. You don't get to choose who's with you. You don't get to choose what you eat. You don't have very much privacy. You don't have a lot of facilities for personal hygiene. You have a pressure to accomplish a task. All that builds up, and that gives you a good resemblance or analog of what a space mission feels like. In the cave, we also have to progress carefully like we would on the outside of the space station. So it puts a lot of the elements together in an environment that is accessible for us on the ground, but that gives the astronauts a lot of the exposure to what they're going to see in the half year that they are going to spend on the International Space Station. Now, how do we get to do all that? The astronaut training is agreed and done with all the 5 partners, the Americans, the Russians, the Japanese, the Canadians, and the Europeans. And it is basically 3 steps that you need to take after you've been selected. We do a basic training that takes roughly 1 year. We're currently in the process of training the 5 people that were selected in the selection campaign that Meganne has introduced. They will finish their 1-year training in April, and they are just back from a survival exercise, being 1 week in the high mountains of the Pyrenees to deal with the snow and the negative effects that has. This basic training really makes sure we have a solid baseline of knowledge and of skills that we can then build on for the assigned crew training once people have been chosen for a mission. Now, we've selected 5 people, but Europe typically has 1 flight per year. So the first person after basic training that gets selected is lucky because that person gets to fly relatively soon. The others will have to wait for 1 or 2 or 3 or 4 years before they actually go into their mission training. And that is what we call pre-assignment training phase. Of course, we train them in the period, but they also help their already selected crewmates to prepare for the mission, and they help them during the mission, for instance, as European communicators, talking from the control center in Munich to the crew on the International Space Station when they have questions, and helping them out doing the job that they have to do on the station. Then, once they go on to an assignment, so they get a mission, then they get another 2 years of training that are dedicated to the task of that mission. So they're looking at the scientific experiments, they are training for repair activities that I've shown are key, they are training on the vehicles that they fly with for both the outward journey and the return journey. So there's a lot of preparation also in there. The good thing, and that's an important aspect, for the astronauts to pass this training, it's always with tests, but if they fail a test, it's not a problem. It's different than in school. If the astronaut fails a test, it's the problem of the instructors. If we haven't trained these highly intelligent and highly motivated people such that they could pass the test, then we've probably made a mistake. That's the big advantage they have over school pupils and university students. An astronaut that does not pass a test, it happens rarely anyway, is not at fault because then we haven't done our job properly and prepared them properly. The training happens around the world because we're 5 agencies and every agency trains only for their components. So the astronauts are moving quite a bit around the planet, and you see here on the map the centers that they go to. They go to Japan, they go to Russia, they go to Europe, and they go to the US. The Canadian training is not shown here on the map. That happens in Montreal. That is a relatively short portion. Large portions of the Canadian training are done actually in Houston. And my last thing is just to show you how busy the training is for an astronaut. You can see here lines of little cubes, and you don't need to read any of that. Just take in the colors. Basically, what I'm showing you is the training plan for all the astronauts that are currently in training on a Soyuz or flying on a SpaceX vehicle. And it always ends on the right side with the red bar, which is the launch. And it starts on the left side, and you see the topmost ones are the ones that are close to launch, and the ones on the bottom are the ones that started the training. And each cell is 1 week of training, and the color tells you where it is. Yellow is Russia, blue is the US, and if you're lucky, you can see the few green or pinkish weeks that are for Japan and Europe. So we're planning at the beginning of this training already a 2-year period for the life of the astronaut. And you can see it is not an easy life because in those 2 years, it's 35 hours of technical training every week. And on top comes all the other things they have to do. So really quite a challenging task, but it is a task that 22,000 people wanted to do. If I could have a choice, I would also be willing to go through that because it is an immense journey. It is fun, and it is certainly also fun to be here on the ground and support that journey and ultimately see the crews that we've worked with fly to the International Space Station. That's it, and I think I'm handing back to Dallas.
Thank you so much. Both of you, thank you so much for such fascinating talks. Yeah. Rüdiger, I was really interested just now with something you said, which made me very, very happy, which was the tests that astronauts do. If they fail a test, it's not their fault, it's your fault as trainers. That's
amazing.
where I was going wrong at school all the time. Every time I failed a test, it wasn't my fault, it was my teacher's fault.
There we go.
I feel vindicated in life. What a brilliant overview.
Honestly,
we've got
so
so many
great.
questions there. I've got so many questions. Meganne, just really quickly, just before we get on to people's questions, I just want to ask, because I know several people who sort of took part in the application process. And I'm just wondering what it was like, first of all, when you got the news, yes, you're in, what that felt like. And also when you sort of turned up on day one, you know, as a sort of newbie, how was that? And your expectations then, how have they kind of manifest themselves? Is it anything like you expected, or is it completely different? Is it? I'm just interested in a little bit of that.
So I got the news while I was riding my bike home from work one evening. I felt my watch vibrating, and I thought, oh no, I'm not going to answer the phone. But then I had a quick look down, and I saw that it was a number from France, and I knew that the headquarters of the European Space Agency is in France. So I thought, okay, I'd better answer this call. And it was the Director General saying, please come to Paris for the announcement of the astronauts next week. So it was hugely exciting, a little bit surreal. At the same time, a relief, because it had been a really long selections process, and finally it was coming to an end. So yeah, excited, relieved. At the same time, I didn't know at that point whether I would be a reserve or a career astronaut. So I found out on the day of the announcement that morning, and there was a little bit of disappointment there, because that meant that I couldn't go straight away to become a career astronaut and do all the training that Rüdiger was talking about. So there was excitement and disappointment and relief all at the same time. And so I haven't really had that first day at training yet. As the reserve, I continue with my job and wait until my chance for training.
I think
we've had some things with the reserves as well, which have been a lot of fun, getting to familiarize ourselves with some of the things that Rüdiger was talking about.
Yeah.
I think I noticed, I think last week you were in America at the, am I right? I saw you at the neutral buoyancy tank in Houston looking at astronauts training underwater. Rüdiger mentioned you've got one of those in Cologne as well. But being in that big neutral buoyancy tank in Houston, that's got to be, because it's such an iconic building, it's such a famous building, watching the astronauts kind of going underwater to work on the mock-up of the ISS. What was that like?
Yeah, it's amazing. It's a huge facility. It's hugely exciting to be there as well, because maybe one day I'll get to do it myself. But seeing the astronauts hoisted into the tank, it just makes you realize how hard work it is to do that extravehicular activity, and how heavy the suits are. Of course, you don't feel that mass in space, but you feel the pressure, and you're constantly working against it. So, yeah, amazing.
Amazing. Rüdiger, we've got this question from St. Mary's Catholic Primary School. How hard would you rate astronaut training on a scale of 1 easy to 10 hardest? I
didn't know if it was to open during the session.
Oh, I think we've lost Rüdiger. He's on mute again. Or maybe he's just thinking really hard. Oh, we've lost his sound. He's on mute. One of the things that does make me happy is that even, you know, doctors like Rüdiger there, who trains astronauts, still struggles with Zoom and Teams calls, which I do as well. So that makes me happy.
I think one question actually here from Brudenell Primary, Sycamore class, perhaps you can help with this, Meganne, which is, my student is wondering if you can explain what G-force is. Because we've talked about it quite a lot today, actually.
We have talked about it,
We haven't really explained what that is.
There you go, it's a physics test for you.
Was that what G-force is?
Yes, they want to know.
Yeah, so it's the force of gravity. And of course, if you're on a rocket heading into space, you feel a lot of that force because you're going so fast and you get pressed back into your seat. It's also what fighter pilots feel when they're going really fast in their aircraft. But it's a bit different to what fighter pilots feel, because they feel it sort of through their head in this direction, whereas astronauts are lying down and feel it through their chest. So funnily enough, it's actually a little bit easier for astronauts to endure. But yeah, it's basically that really heavy feeling that you get when you're going very, very fast.
Rüdiger, have we got you back? Can you hear us? Oh, I'm not sure. I'm not
sure.
not sure we have. Meganne, just very quickly, what was for you when you were doing the selection process? A lot of people were wondering what that selection process was, and you mentioned that actually the first set of interviews you found the hardest thing. What was it about that was so nerve-wracking? Talking to people who've been through that process, they all have different horror stories of things that they were not very good at, or things they struggled with.
Yeah, that's right. So I think each step of the process was difficult in its own way. And yes, that first set of exercises was particularly difficult because for example, they had some really tough memory exercises.
Horrific. I tried them. Learning numbers, repeating numbers backwards and this kind of thing. It gives me a nightmare thinking about it.
They'd recite a bunch of numbers to you and you had to memorize them and type them backwards. Wow. And they could have 20, 30 numbers and you had to remember as many as you could. So yeah, that was tough. But for me, the hardest part was actually the panel interview towards the end. Just because it was there was a lot of pressure.
That's it.
I don't know if I could do that personally. Like hearing you talk about it, I'm like, I would crumble.
I sort of think though, I mean, meeting astronauts, and I don't know if you agree, Meganne, it's like who would you rather go? Who would you like to go camping with the most? Seems to be the kind of. It's as much about being a personable human being as it is about being good at maths and physics. Given that space flights are going to get longer in duration and getting on with people, and actually the role of the astronaut has changed such a lot. It's not just doing experiments, but it's also talking to the public and being able to communicate what it is that you're doing.
Yes, absolutely. And that's why experiences like the one I had in Antarctica and what the astronauts do during survival training or the caves in Pangaea, they really help to build those relationships with people that you don't necessarily know beforehand, and you haven't chosen them, but you have to get along well with them. So it's a big aspect of it all. Teamwork, being able to be a leader, but at the same time being able to be a follower. Yeah.
And someone says here, at what age should you start your astronaut training?
Well, you can start at any age, but what I always tell people is that you should just find something that you enjoy, because you have to be good at something else before you can then apply to become an astronaut. I was talking about the requirements before. So you have to have at least a master's degree and 3 years of experience, and you might as well be doing something that you really love. Now, the chances to become an astronaut are going to increase in the future, but it's still a relatively small amount of people that actually get to do it. So do something that you love and you'll be fulfilled whether you're selected as an astronaut or not.
That is the best advice yet. It's that thing, and if you want to be an astronaut desperately, you're probably the wrong person to be an astronaut. Have other interests in life. Be a well-rounded human being.
Find that passion.
Yeah, exactly. That's what you need. Genuine passion. Rüdiger, do we have you back? Are you still? We can see you, but I don't know if we can hear you. I'm sure that we've got lots of questions for you, but we can't hear you, unfortunately, sadly.
That's such a shame.
Maybe we could do sort of sign language or mime. We could mime the questions to you. I was interested actually because I went to the Astronaut Centre in Cologne a couple of years ago actually, and then they were sort of thinking about doing lunar surface exploration in the bottom of the neutral buoyancy tank there, and thinking about those. I wanted to ask Rüdiger about that.
But there's actually a new facility being prepared right next to the European Astronaut Centre called Luna, where it will be just like the lunar surface so that astronauts can train. And also people who want to do experiments on the moon in the future will be able to test out their experiments in an analog sort of environment.
That's right. They were doing, when I was there, they were doing sort of sintering of simulation lunar dust to make bricks, thinking about how we can build structures on the lunar surface that astronauts can live in.
Amazing. Well, thank you so much for joining us. Thank you, Rüdiger, and thank you, Meganne. I'm inspired. I'm probably not going to make it as an astronaut, but hey.
I'd be the worst astronaut on Earth, but that's okay. It's always a pleasure to talk to astronauts, and it's lovely to hear about the training. It's lovely to see your enthusiasm, and congratulations as well. Congratulations for being one out of 22,500 people. That's got to be good for the ego, hasn't it?
It is, but there's still a little bit of imposter syndrome there, because I met so many wonderful people during the selections process that could have been good astronauts as well. So Yeah, I'm still amazed that it happened.
Well, congratulations. It's well deserved.
Marvellous. And we'll see you later on your talk this afternoon as well. So make sure everyone else tune in for that this afternoon.
Rüdiger, thank you so much as well. If you can hear us, sadly we can't hear you, but thank you so much. A wonderful talk. It's lovely to see you, and congratulations and well done for training your astronauts so beautifully.
So I think we should do some shout-outs.
Yes, some shout-outs. Who have we got to shout out to?
Shout-out to St Mary's in Whitstable, and shout-out to Brooklands Primary in Belfast. We've got Year 5 at Croft Primary as well are here with us. Gosh, there's so many of you here. Thank you so much. We've got Year 5, Jessie Gray in Nottingham.
Hi, Jessie.
And also, I think it's important to say that this is Mars Day.
Yeah.
But Mars Week is an entire thing.
Oh, yeah. We've got a whole thing about Mars Week here. Look, so the Mars Week sheet.
So it's from today until the 10th of March.
Yeah.
And we've got lots of different talks going on in the evening. There's one on later today starting at 4 p.m. if, you just want even more Mars Day.
Yeah.
But yeah, make sure you check the website because there's loads and loads of different talks going on. I think there's like a guide to studying the moon and things like that.
There's all kinds of things. And the thing is as well, is when I can't remember who I was talking to earlier on about this. When I was young, we were talking to Tim about this.
Yes.
When we were young, space is something that the Americans did.
Yeah.
They launched the shuttle and that was kind of it. It seemed a long way away. But these days, if you are interested in space, whatever it is that you're interested in, there'll be something there for you to do.
Absolutely. This afternoon's talks, we've got science in space, engineering in space, technology in space, maths in space. So many things to do in space.